Hi, welcome to my video on word problems using logs. And the word problems I'm going to do is pertaining to the exponential, because the exponential function is the inverse of a log. So you have to have gone or done the unit on exponential, where you have word problems on interest rate, compounding, you have growth and decay, you have doubling time, half-life, etc. So it's imperative to have done the unit on exponentials. Let's do some problems. A painting in 1980 sold for $120,000 at an annual rate of increase of 2.7%. What year did the painting sell for $148,506? Well, there's a problem. We have N and NO. NO is the original cost, and 1 plus the rate, and it's T over C. T is the time in years, and C is the increment change. So what happens is that we have NO is originally 120,000. We have the rate is 8%. And the increment change is happening every year. Oh, sorry, I said 8%. Now, why would I say 8%? 2.7%. Sorry about that. And the increment change, C, is 1. So what we have is 120,000. And we also have that N is 148,506. So we have 148,000. That's 148,506. The initial amount is 120,000, and it's 1 plus the rate, which is 2.7%. And we're looking for time, which is T, and the increment change happens every year. The increase is 1. So let's tidy this equation up, and we have 148,506 is 120,000, and 7%, or what did I get 7% again? 1.7% is 0.027. We moved the decimal 2 places to the left. So that becomes 1 plus 0.027 to the T. So we have $148,506, 120,000, and that's 1.027 to the T. So if we divide by 120,000 on each side, we could leave it as that. Take 148,506 divided by 120. That gives us 1.23755 if you use your calculator, and it's 1.027 raised to the T power. Notice that we're looking for time, and time is in the exponent, so that means we have to do a log. So let me change the equation around. I like to have the equation in this order. Just something, a habit I get used to. So I'll do the log of both sides. So 1.027t equals the log of 0.23755. And the t goes in front because of the power rule. And we divide by the log of 1.027 on each side. So right here, t is equal to, and we take our calculator and we do the log of 1.2375 divided by the log of 1.027 0.27, and that number comes up to be 8. You can use your calculator and I'll show it to you. So here it is. Okay, just pick up that number first. And we have the log of 1.23755 division, and the log of and it's 1.027, and that should give us 7.999. So you can see that's 8 years. So in what year? Well, you take 1980, add on 8, so the year is 1988 when the painting was sold. Okay, let's do another one. The half-life of a substance is 80 years. To the nearest year, how many years will it take for 250 grams to become 100 grams? Notice this is a decay, it's going down, and we have a half-life. So the equation for a half-life is N equals NO. Half-life is the base, that's 50% reduction, and it's T divided by H. So we have, originally it started with 250, and it's going down to 100, half-life, and we're looking for the time, number of years is T, and the half-life is 80. Again, the exponential unit has to be gone over in order to do these. So we take the 250 and divide into the 100, so that gives us 0.4. 100 divided by 250 is 0.4, and it's a half raised to the T over 80. And again, I like to go a half T over 80 equals 0.4. Do the log of each side. And the power is T over 80, goes in front of the log, 1/2. And now we divide, so it's T over 80, and it's the log of 104 divided by the log of a half. And so to work that out, we can say, we cross multiply. So T times the log of a half equals 80 times the log of 0.4. So T is equal to 80 log of 0.4 divided by the log of a half. The log of a half is 0.5, so I can put half in the calculator. So you pick up the calculator and you work out this. Let's clear it. So we have 80 and times log of 0.4, log of 0.4 or just 0.4, and division log of 0.5 or just 0.5. And so T becomes 105.75, and that's in years, so the answer is roughly 106 years. If you want to go to the nearest year, 105.75 or 106. Again, notice that we're looking for time, and time is in the exponent, so we have to do the log. And this one is a little different equation. This time I'm giving you the equation. Vt equals 6 times 0.9 to the T plus 10. Represents the volume of air in the balloon at T days. Notice notice that the base here is 0.9. So 0.9 is a decay. And just to do a little bit of work, the base is 1, again is 1 minus r. So the base is 1 minus r. So this is a little bit extra. So if you continue, move r to the right and move the 0.9 to the left, r is 0.1. So r is 0.1 is 10%. So this is a little bit extra. I'm just trying to illustrate, since that's smaller than 1, this is the decay. That means the balloon is not increasing in size, it's decreasing. So we have, we want to find out when the volume is 15. So 15 equals 60, 0.9 to the t plus 10. And we have to isolate this part. So 15 minus 10 is 60, 0.9 t. Again, notice we're looking for the time, and that tells us that we're going to have to use a log. So 15 minus 10 is 5. And we divide by 60 on each side. So we get 0.9 t. And 60 is 1 over 12. Now I could do a decimal for 1 over 12, but I'm going to leave the 1 over 12 there. Again, I'm going to change it around. I like to have it with the power on the left side. So I'll do the log of each side. And t equals, t log 0.9 equals log of 1/12. And we divide by the log of 0.9. So t is equal to, that cancels. So pick up our calculator, and I'll write that down first. This is the log of 1/12 divided by the log of 0.9. So just be careful using your calculator now. I got the log of, clear that. I'm going to do the log. So that's 1 divided by 12. So that's 1 division 12 enclosed in a bracket. And I'm going to divide it by the log of 0.9. And that gives us 23.58. So that's the number of days to the nearest day. So, whoops. That's 23.58 ... It's an irrational number. So the answer to it says to the nearest day. So in 24 days, the balloon would have a volume of 15. And one more to do. The population of a town increases 8% per year. So the rate is 8%. Find to the nearest year when the population will be doubled. So the equation is that we have the original population growing to p, which is the population after t. So that's 1 plus the rate, and it's t over c, which is the increment change. And it happens every year, so c is 1. So it's going to double. You say, well, I don't have any population. So that means that p is twice PO. So whatever this population is, it makes no difference. This is going to be double. So if this is 5,000, this would be 10,000. So if you had 5,000 divided into 10,000, you would have a 2. So the rate is 8%. And we're looking for to the nearest year when it's going to double. And it's every year, so that's a 1. So P, 2PO divided by PO is an 8%. So let's work that out so we don't have to work it all the way down. 8% is 0.0 8, which is 1.08. So this is 1.08 to the t. So p divided by po, so that's 2 equals 1.08 to the t. And again, as I said, if that was a 5,000, this would be doubling to 10,000. 10,000 divided by 5 would give you the 2. So it don't make any difference what the population is doubling, so there's the 2. So 1.08 raised to the t power equals 2. We do the log of each side. Why? Because we have the, as we say, we have the t is in the exponent, so the log will bring it down to the front. So t log 1.08 is log 2, and we divide by log of 1.08. So t is equal to the log of 2 divided by the log of 1.08. And so t is equal to the log of 2. Use my calculator now. Here we go. So we have the log of 2 division log 1.08. Oh, I didn't do my division. No, look. No, I made an error here. I looked. That's decimal. That's not even a 100 of a year. So I made an error. So I didn't do my division. So it's the log of 2, recognizing the division. And I knew I was wrong. When you make an error, you try to, the answer, has to be bigger than 1, because it's 9. So t is 9. You can see 9.006, so 9 years to the nearest year. So 9 is the answer. So the answer is 9 years. And notice the population is increasing, so time had to be bigger than decimal 0.1. So I knew I had a mistake. So that's some word problems using logs. And again, we use logs because we want to get at the x, which is in the exponent, or in this case, we get at the t, which is the time. Time is the exponent. And if this is the last video that we'll do, there's one more coming after this, and it will be on the review on videos. I think it's videos, I'm not sure, 14 to the end. So if you like my video, click on the like button. If you want to subscribe to my channel, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.